Today we're going to take a look at section 10.3, day number 3. Previously we've added and subtracted radicals, we've also multiplied radicals, and the third day here we're going to take a look at dividing radicals. Okay? There's when we divide little expressions with radicals in it, there's one rule about your answer, is you're not allowed to have radicals in the denominator of your answer. Okay? So for example, if I had 2 over the square root of 3, okay? Not allowed to have our answer in that form. Okay? We're not allowed to have this radical in the bottom. So how do we go about getting rid of it? Okay? Here's how we go about getting rid of it. If I had 2 over the square root of 3, okay, the way we get rid of a radical in the denominator is we multiply the top and the bottom by that radical that is in the denominator. So what I mean by that is I'm going to multiply the top and the bottom by the square root of 3 over the square root of 3. And I'm allowed to do that because this is essentially just 1. If I cancel itself out, it's a 1, and if I multiply anything by 1, it does not change its value. Okay? So we're going to multiply by that radical and watch what happens. My numerator, if I multiply, just becomes 2 square roots of 3. The denominator, if you remember from a previous lesson, the square root of 3 times the square root of 3 is just plain old regular 3. The radical part kind of cancels out, and I just get that left over. Okay? Once I multiply with these, I should always check 2 things. I should check the radical part. Is that radical part in simplest form? Yes, it is. And the second thing I need to check is, can I simplify anything with the big numbers out in front? Okay, in this particular case, I cannot. And there's my answer, 2 square roots of 3 divided by 3. Okay? Oops. Okay, we're taking a look at a couple others here real quick. Okay, what if I had this? 4 square roots of 2 divided by 5 square roots of 6. Let's take a look at that one once for a minute. Okay, now again, in the denominator, I have 2 things down there in the denominator. I have a 5 and a square root of 6. The 5 is okay. The big number is okay. It's just the radical that I'm not allowed to have. So I'm going to multiply the top and the bottom by that radical. Okay? If you watch what happens here, on the numerator, the 4 stays put, but the square root of 2 times the square root of 6, I get 4 square roots of 12. Okay? The denominator, again, the square root of 6 times the square root of 6 turns into big 6, and 5 times 6 is 30. Okay? And look closely at this part of it. I don't have a radical down there in the denominator anymore. That's a good thing. However, in my numerator can be simplified. Again, if I look at the radical part, if I go to my factor sheet, the square root of 4 times the square root of 3, 4 turns into a 2. If I look at what I have now, a big 2 and a big 4 is 8 square roots of 3 over 30. Okay, so I got the radical simplified. Now let's look at the big numbers. What about 8 and, 8 square roots of 30. Let me rewrite that again. What about my big number? Can something be divided into each of those? Yeah, if you look closely, a 2 can be divided into each one. So if I divide both by 2, I get a 4 and a 15. And that's as far as we go, so my grand finale answer is 4 square roots of 3 over 15. So there's one where after I multiplied, the radical could be simplified, and also after I simplified, the big numbers could be simplified. Okay? Let's take a look at one more here. One more of these. Oops. Okay. What if I had one where the numerator how about that? What if the numerator had a little bit more to it than just a single term? What instead of a monomial, what if the top is a binomial? Okay? Well, I don't care about the top right now. Let's look at the denominator. And the bad thing about the denominator is there's a radical there. Can't have it. So let's get rid of it. So I'm going to multiply the top and the bottom just by the square root of 6 over the square root of 6. Okay? I can do that. Okay? Now what happens up here in the top, that gets grouped together, and we're going to end up doing a little distributing. Okay? If I go here to the left, 2 times the square root of 6 is just 2 square roots of 6. And then the square root of 3 times the square root of 6 is the square root of 18. Okay. If you look at your denominator, the square root of 6 and the square root of 6 turn into big 6, and 3 times 6 is regular 18. Okay? So I got rid of the radical in the denominator, that's a good thing. But let's look at our numerator. Can anything be simplified up there at the top? Well, the square root of 6 can't be, but 9 can be. 18 can be divided into 9 times 2, and 9 turns into a 3. Okay? So let's go. I have 2 square roots of 6 plus 3 square roots of 2 all over 18. And if I look closely at that, my two radicals are reduced all the way. And then my big numbers, 2, 3, and 18, okay, there isn't anything that goes into all 3 of them. Now 2 goes into 18, 3 goes into 18, but 2 and 3 don't have anything in common. There's my final answer right there. Okay? Let's practice one more of these real quick. Okay? How about this one? How about just 5 over 4 minus 3 square roots of 2? Okay? Oops, sorry, that's not what I wanted. My bad. Other way around. 4 minus 3 square roots of 2 over 2 square roots of 8. How about this? Again, I have a radical down there in the denominator, the square root of 8. Let's multiply the top and the bottom by the square root of 8 over the square root of 8. My numerator, I'm going to have to distribute. Out front here becomes 4 square roots of 8. And this becomes negative 3 square roots of 16. Okay? My denominator, the square root of 8 times the square root of 8 turns into a big 8, and 2 times 8 is 16. Okay, so I got rid of that radical in the bottom. It's not down there anymore. But I have a couple radicals up here in the top. Let's see if they can be reduced at all. How about the square root of 8? Well, the square root of 8 can do 4 and 2. The square root of 4 is 2. Oops. Okay. So I have 2 times 4. This 2 times that big 4 is 8 square roots of 2. How about this one? Oh, hey, look at that. The square root of 16, that's a nice number. That's 4. And 3 times 4 is negative 12. All over 16. Okay, so I've reduced each of my radicals. Now let's look at these big numbers. Can something go into all 3 of those? And if you look carefully, 4 can be divided into all 3 of those. So I'm going to divide out a 4. I get a 2, a 3, and a 4. And that leaves me with 2 square roots of 2 minus 3 all over 4. Okay? But again, the big thing here is to get rid of the radical, we multiply the top and the bottom by that radical. And then it's multiplication like we saw in our previous lesson. But just make sure also at the end you double check and triple check to see if you can reduce everything or anything, whether it's the radical part or the big number part. Okay? Well, I want to point out here that if you notice, all of these denominators, maybe you haven't noticed, but all these denominators have just had one term to it. There's not been any addition or subtraction down there in the bottom. It's just been one thing. Okay? Well, my question is, what if I had something that looked like this? 3 over 2 minus the square root of 5. What if the denominator had more stuff down there? It had 2 terms instead of just 1. And notice it's 2 minus the square root of 5, so that's 2 down there. Well, I can't just multiply the top and the bottom by the radical here when there's 2 terms. When this is the case, we have to multiply the top and the bottom by this thing called the conjugate. Okay? And this is what the conjugate is. It's the same numbers down there, but it's just a different sign. So instead of 2 minus the square root of 5, it's 2 plus the square root of 5. Okay? That right there is what's called the conjugate. Okay? Same numbers, different sign. Well, this is going to entail a little bit of work. Okay? We're going to distribute through the top. 3 times 2 is 6. 3 times that is plus 3 square roots of 5. Okay? The denominator, you're going to see a little magic trick here. Watch what happens. 2 times 2 is 4, plus 2 square roots of 5. Then I go to this one and I multiply. I get minus 2 square roots of 5. And then the square root of 5 and the square root of 5 turn into a minus 5. Okay, now look at those middle terms. What happens with the positive 2 square roots of 5, minus 2 square roots of 5? They disappear, they cancel out. They're gone. And the only thing left is 4 minus 5, which is negative 1. Okay? And notice the denominator does not have any radicals in it. They're gone. So again, it's okay to have a radical in the top. The radical simplified, nothing else can go in there, and we got it. Now one thing I should mention while I see this one, I see a negative 1 down here in the bottom. We usually don't see negative signs down in the denominator. You can leave it there, but usually what they're going to do is they'll move it to the top. And what that does is it makes the 6 become negative, and make that become negative 3 square roots of 5, and then it's over positive 1. So either one of those answers is okay. The reason I mention that is on an answer key somewhere, it's probably going to have that one instead of that one, but just note that they're really the same thing. Okay? But the big thing here is this keyword is called the conjugate. Okay? You need to multiply the top and the bottom by that conjugate, and I need to see that. Okay? And obviously these require a little bit of work. Okay? All right, we're going to take a look at just a couple others here real quick. Okay? What if I had this one? 2 square roots of 5 over 3 minus 2 square roots of 3. Okay, how about this? Well, I look down there in the denominator, and there's a radical, and there's addition or subtraction in there. So I'm going to multiply the top and the bottom by the conjugate. The conjugate of 3 minus 2 square roots of 3 is 3 plus 2 square roots of 3. Okay, and that's what we're going to multiply the top and the bottom by in this case. Okay, and once again, okay, we're going to do a little distributing. That first one becomes 2 times 3, 6 square roots of 5. And this one becomes 2 times 2 plus 4 square roots of 3. The denominator is another, it's going to be a FOIL problem. 3 times 3 is 9. And then this one is plus 6 square roots of 3. I go to that one, it's minus 6 square roots of 3. And they're always going to cancel out. Okay? And then be careful of the last term here. 2 times 2 is negative 4. The square root of 3 times the square root of 3 is 3. And that turns into negative 12. 9 minus 12 is negative 3. Okay? And then we're back to what we have to check before. The radicals are simplified, the 5 and the 3. And the big numbers, 6, 4, and 3, there's nothing that goes into all three of them. There's our answer right there. Okay? But again, the key is we multiply the top and the bottom by the conjugate. And you have to show your work to do that. Okay? All right, the very last type of problem we're going to see is the same thing, just a little bit fancier. Okay? How about this one? 6 plus the square root of 2 over negative 5 plus the square root of 6. Okay, now the top and the bottom are both binomials. This is the fanciest type of problem you're going to see. Okay, I want to multiply it. I see a radical down here. It has 2 terms, so I have to multiply by the conjugate. The conjugate of negative 5 plus the square root of 6 is negative 5 minus the square root of 6. Notice the 5 still stayed negative. It's only the addition or subtraction sign that changes. Okay, and this becomes a little bit fancier problem. This is going to become a FOIL problem. I'm going to have to FOIL the top and FOIL the bottom. Okay, well, let's try FOILing the top here. 6 times negative 5 is negative 30. Minus 6 square roots of 6. Then I go to this one. Minus 5 square roots of 2. And the last one, the square root of 2 times the square root of 6 is negative square root of 12. Okay? If I look at that numerator, are there any like terms that we can combine and simplify? Doesn't look like it. Are the radicals all simplified? The square root of 6 is, the square root of 2 is, but this one isn't. 4 and 3, that turns into 2 square roots of 3. it still doesn't help me. It still doesn't get me anywhere. So my numerator is just going to be that great big long expression. Nothing could be combined or simplified, and that's okay. Okay? Let's look at our denominator. Negative 5 times negative 5 is 25. Here I get plus 5 square roots of 6. Negative 5 square roots of 6. I know they go away. And the square root of 6 times the square root of 6 is just negative 6. The radicals cancel out. 25 minus 6 is 19. And if I look carefully at those, none of the big numbers have anything in common with 19. There's my answer right there. Okay? So again, the key to the game here in getting rid of radicals in the denominator is we multiply the top and the bottom by the radical. Okay? If there's just one term down there in the bottom, oops. If there's just one term, a monomial, then we can multiply the top and the bottom just by that radical. Okay? But if there's more than one term down there in the bottom, if there's addition or subtraction, then you have to multiply by the conjugate, and it becomes a little bit fancier problem. Okay? So those are the two types of things that you're going to see. All right, thanks for tuning in.